Hello everyone and welcome to G Fun Facts Online. Today we are going to dismantle the way you think about dinner. I want you to start by imagining that you are sitting down at your absolute favorite high-end steakhouse. The lighting is dim, the tablecloth is crisp white, and the waiter places a sizzling ribeye right in front of you. The marbling is perfect. The aroma is intoxicating. You grab your knife and cut into it, revealing that tender, medium-rare pink center. You take a bite, and it tastes exactly like the best beef you have ever had. But there is one crucial difference with this meal. No cow was slaughtered to put this steak on your plate. In fact, this steak didn't come from a farm at all. It was born from a biopsy the size of a sesame seed and constructed, layer by microscopic layer, by a robotic arm in a sterile facility. Welcome to the dawn of the 3D printed meat revolution. This is not science fiction, and it is not some distant dystopian dream. It is a rapidly crystallizing reality occurring in laboratories and pilot factories right now, from Tel Aviv to Singapore, and from Silicon Valley to Maastricht. We are witnessing the convergence of two of the most transformative technologies of the 21st century, tissue engineering and additive manufacturing. Together, they promise to upend the 12,000-year-old history of agriculture, offering a solution to some of humanity's most pressing existential threats, like climate change, food insecurity, and animal welfare. But beyond that, it promises a culinary future where our food is programmable, personalizable, and arguably more perfect than nature ever intended. Today, on G Fun Facts Online, we are doing a deep dive into the science, the industry, and the future of printing your dinner. To understand where we are going, we first have to understand the limitations of where we are. Traditional animal agriculture is a resource-intensive behemoth. It utilizes approximately 77% of the world's agricultural land, yet it supplies only 17% of humanity's caloric supply. That is a staggering inefficiency. It is a primary driver of deforestation, a massive consumer of fresh water, and a significant contributor to greenhouse gas emissions. By some estimates, animal agriculture produces more greenhouse gases than the entire global transportation sector combined. For decades, the only alternative we had was plant-based analogs. You know the ones, the veggie burgers that, while noble in intent, often failed to capture that primal sensory experience of eating meat. But then came the pioneers of cellular agriculture. In 2013, Dr. Mark Post of Maastricht University unveiled the world's first lab-grown burger. Now, this burger cost $330,000 to produce, and the verdict? It was dry and tasteless. It lacked the fat and connective tissue that gives meat its succulence. But, despite the culinary disappointment, it proved a massive scientific point. We could grow muscle outside an animal. However, scientists quickly realized that a pile of muscle cells is not a steak, it is a paste. To recreate the complex architecture of a ribeye or a salmon fillet, you need the interplay of muscle fibers, fat cells, collagen, and blood vessels. Scientists realized they needed a way to organize these cells in three-dimensional space. Enter 3D printing. So, let's get into the mechanics of this. How do you print life? The science of 3D printed meat is a marvel of biological engineering. It is distinct from 3D printed plant-based meat, which usually just extrudes soy or pea protein pastes. True cultivated 3D printed meat involves a biological process that mimics the healing capability of an animal. It is a multi-stage process, often referred to as the cellular symphony. Step 1 is the biopsy and the bank. The process begins with a harmless biopsy from a living animal, whether that is a cow, chicken, pig, or fish. Scientists isolate stem cells, which are the body's master builders. These cells have the miraculous ability to self-renew and differentiate into specialized cell types. They are placed in a nutrient-rich soup, called a culture medium. This medium contains amino acids, glucose, vitamins, and growth factors. This environment mimics the warmth and nourishment of the animal's body, effectively tricking the cells into believing they are still inside the host. Step 2 is the proliferation phase. Inside massive stainless steel bioreactors, these cells multiply exponentially. A sample the size of a peppercorn can theoretically produce tons of meat, but at this stage the result is just an amorphous slurry of cells. To become meat, they need structure. This leads us to step 3, the bioink. This is where the actual printing magic happens. The living cells are mixed with a hydrogel to create bioink. This ink is the crucial medium that protects the cells during the printing process and provides them with a temporary home. The hydrogel is often made from natural, edible materials like alginate from seaweed, chitosan, or collagen. It acts as the scaffold, a lattice structure that holds the cells in place. Then comes step 4, the print. A specialized 3D bioprinter reads a digital file, a computer-aided design or CAD model of a steak. The printer features multiple nozzles. One nozzle might extrude muscle ink, another fat ink, and a third vascular ink. The printer lays these down with micron-level precision, following the exact marbling pattern of a Wagyu beef or the flaky layering of a salmon fillet. Finally, we have step 5, the maturation or the post-print life. When the printing is done, the product is not yet meat, it is technically a pre-tissue. The printed structure is returned to an incubator. Here, the magic of biology takes over. The scaffold degrades or integrates as the cells communicate with one another. Muscle cells fuse to form fibers. Fat cells accumulate lipids. The tissue actually contracts and exercises itself, gaining density and texture. Over a period of weeks, the printed construct matures into a biologically identical piece of meat, indistinguishable under a microscope from its farm-raised counterpart. Now that we understand the how, let's talk about the who. A global race is underway to dominate this nascent industry, with different companies betting on different technologies and culinary niches. Let's look at a few key players. First, there is Aleph Farms from Israel. Perhaps the most famous name in the sector, Aleph Farms made headlines by 3D printing a small steak on the International Space Station. This proved that meat can be grown in zero gravity with minimal resources. Their focus is on high-fidelity, whole-cut steaks. They utilize a proprietary 3D bioprinting platform to create thin steaks that have the texture and mouthfeel of beef, focusing heavily on the vascularization challenge to ensure nutrients reach the inner cells of thicker cuts. Then we have Stakeholder Foods, formerly known as MeTech 3D. This company is pushing the industrial boundaries. They are developing massive, high-throughput bioprinters capable of printing tons of meat per day. Their technology focuses on biopumping, where the printer deposits layers of proprietary bio-ink tailored to differentiate into fat and muscle. Their goal is interesting. They want to sell the printers and the ink to food manufacturers, effectively aiming to become the HP of the meat world. Another major player is Redefined Meat, also from Israel. While currently focusing on plant-based ingredients, Redefined Meat is crucial to the conversation because of their mastery of alt muscle, alt fat, and alt blood. Their new meat printers are so precise, they can digitally program the exact tenderness and juiciness of a flank steak. Their matrix technology maps millions of 3D points to recreate the chaotic, non-uniform texture of real animal muscle, solving the uncanny valley problem of food. And we can't forget the seafood. Revo Foods in Austria is focusing on the ocean. They use 3D printing to recreate the complex orange and white layering of salmon fillets. Their technology addresses the urgent need to reduce pressure on global fish stocks, offering a product that is rich in omega-3s but free from the microplastics and mercury, increasingly found in wild fish. This brings us to one of the most exciting aspects of this technology. It's not just about replication, it is about optimization. This is the customization revolution. Because the meat is built pixel by pixel, or voxel by voxel, it is fully programmable. Imagine a steak where the fat is not saturated animal fat, but replaced with heart-healthy omega-3 fatty acids or avocado oil, yet it still sizzles and tastes like beef tallow. Imagine a pork chop fortified with extra iron or vitamins for anemic patients. Imagine a texture dial where you can choose melt-in-your-mouth tenderness for the elderly, or a chewier, fibrous texture for a barbecue enthusiast. This is the era of personalized nutrition. In the future, your smartwatch might detect a protein deficiency or high cholesterol, send data to your kitchen printer, and customize your dinner's nutritional profile in real time. We are moving from a one-size-fits-all food system to one that is distinctly made for you. Of course, we have to talk about the sustainability and ethical calculus. The environmental argument for 3D printed meat is staggering. Oxford University research suggests that cultured meat could be produced with up to 96% lower greenhouse gas emissions, 45% less energy, 99% lower land use, and 96% lower water use than conventional meat. In a world approaching a population of 10 billion, where arable land is shrinking, this efficiency is not just a luxury, it is a survival mechanism. It allows us to return vast swaths of pasture land to nature, restoring biodiversity and carbon sinks like forests. Ethically, it decouples meat consumption from animal suffering. For the first time in history, a vegetarian could theoretically eat meat without compromising their values. It eliminates the need for antibiotics in farming, which is a major driver of superbugs, since the meat is grown in a sterile environment. It also removes the risk of zoonotic diseases, like COVID-19 or avian flu, jumping from livestock to humans. However, we cannot be naive. Despite the promise, the path to a printed dinner is paved with obstacles. These are the great hurdles. First is the cost of the ink. Currently, the growth medium used to feed the cells is astronomically expensive. Historically, this medium relied on fetal bovine serum, or FBS, which was both costly and ethically controversial. The industry is now racing to develop plant-based, animal-free growth media that are cheap and effective. Until the cost drops from thousands of dollars per pound to tens of dollars, it will remain a niche luxury. The second hurdle is the vascularization challenge. Printing a thin burger is relatively easy. Printing a thick 2-inch ribeye is incredibly hard. In a living animal, blood vessels transport oxygen to every cell. In a printed steak, without a vascular network, the cells in the center of the meat would die and rot, a process known as necrosis, before they could mature. Scientists are developing sacrificial inks. These are materials printed to form channels that melt away later, leaving hollow tubes for nutrients to flow through, effectively creating artificial veins. Then there is the yuck factor. Consumer psychology is a fragile thing. To many, the idea of meat grown in a tank and printed by a robot feels unnatural, sparking fears of frankenfoods. The industry faces a massive PR challenge to normalize the technology, framing it not as lab-grown but as clean meat or cultured meat, analogous to how beer is brewed or yogurt is cultured. Finally, regulation. Food safety agencies like the FDA in the USA, EFSA in Europe, and SFA in Singapore are charting unknown waters. How do you inspect a slaughter-free slaughterhouse? Singapore became the first country to approve the sale of cultured meat in 2020, and the US followed with approvals for Upside Foods and Good Meat in 2023. But global regulatory alignment is still years away. So what does the future hold? Let's look at the landscape for 2030 and beyond. We are currently in the roadster phase of this technology. High cost, low volume, high excitement. By the late 2020s, we will likely enter the Model S phase, seeing premium products available in high-end restaurants in major cosmopolitan hubs. By the 2030s, we may see the hybrid era dominate. These would be products that are 50% plant-based protein for bulk and cost, and 50% cultivated animal fat for flavor, printed together to create affordable, tasty burgers and nuggets. And by 2050, the 3D food printer might be as common a household appliance as the microwave. You might download a recipe from a celebrity chef, buy a cartridge of Wagyu stem cells and vegetable scaffolding from the grocery store, and print a Michelin star quality dinner while you finish up work. In conclusion, printing dinner is not merely about novelty. It is about necessary evolution. We have reached the biological limits of the cow and the chicken. We cannot breed them to grow faster or use less water without creating ethical monstrosities. To feed the future, we must transcend biology's limitations, stripping meat down to its cellular essence and rebuilding it with the precision of engineering. The 3D printed steak represents a shift from extraction to creation. It is a culinary canvas where science meets sustenance, promising a world where we can have our steak and eat it too, without killing the planet or the animal. The cellular revolution is here, and it looks delicious. Thanks for listening to G Fun Facts Online.